All right. Hello, Ed. This is Brian Raya with the final for networking. I'm currently at home right now, so I don't have access to two computers, but the process is the same right here. Both of my systems are asking for an IP address, and the connection should be okay. Um, right here in my project folder, there's a single Visual Studio solution that will be opened on both machines. In my case, one. And I also have the checklist here in Word format and raw text format. Um, I'll start off with one of the computers. So this computer will attempt to connect to localhost, but since localhost doesn't exist, what the process does is it will send multiple packets. Oops. Host. My bad. It will send multiple packets to that IP address, which is localhost, and the port number is 60641. Since at that moment it did not exist, we receive a disconnect, we shut down, and we become the server at this point. We are now bound to our IP address and the port number being 60641. So now that the port number 60641 exists and is on this IP address, we type in the IP address of the first computer or the now current server. In my case, again, it's localhost. We press enter. And at this point, we receive the connected message. So we've connected on both sides. At this point, we can press space on either one of the two screens, and we enter the actual game. For the purposes of the demo, I wanted to speed this up. I removed all the lives so that way you can see the game switch for points, and then for the end screen. So this is player one side. I can control this ship. I can fire missiles. I can lay down a mine. I think it's C. Yeah. And that happens. This is player two. On player two side, I can only control player two. I can fire player two's missiles. I can drop a mine for player two, and so forth. And I guess I'll do this. I'll attempt to destroy player two. Okay, fire. Okay. I've killed player two and I've done my switch, so I've received my point. Player two received its death, and it's at my point. And now I'll just go up and hunt over player two to show the win screen. There's the win screen. I press space again. I am now at this on this screen. And if I press space one more time, I've entered the game again. That's basically the process. You can play again and again and again. And when I do the final submission for this, I'll set the players' lives back to the original, which was the 4, and the final score counter to be the original numbers. I merely reduce them just to speed up the process of this demo. As you've seen, there is collisions, there is mines, there's everything in the process is there. And I'll go into the code just to demonstrate what that is. So I'll close down player one, and I'll open up the project so we can go through the code line by line. So in the very beginning, we have a console window that comes out, and what we do is we ask for an IP address, and we store that into our network listener. When the game goes through its initialization phase, we start up the network listener. We'll go into that. And what we do is we start off as a client with a maximum number of handshakes as 1. So we send a single packet and we wait about 3 seconds to see if we receive anything back. And if we haven't received anything back after 3 seconds, then we continue on with the process. But I'll go through that right now. We attempt to connect to the server port 60641. That will be the default server port for the game. And the target was the IP address that the user typed in. In my case, it was localhost, but it could be any other IP address. Then what we do is we try connecting. So we send the packet over to try and connect, and then we wait to see if we receive a message. So we call this process private message, which returns an int depending on what the message was. In our case, the only one that we're worried about is right here. So we keep listening and listening to see if there's been a status change message. We read that message, and if we've connected, then we're fine. We don't do anything. We just list off that we're connected. But if we haven't connected to anything, then we receive the status of disconnected. And what we do is we create our server, and we have our return code B0. Under this case, we'll go into it. We shut down our current connection, and we process that to make sure that this shutdown has fully happened. And then we give our server information. I have this extra write line to say that we become the server. It's not really necessary since the process works. While we're also in here, it may be important to go through the other things that the private process does. And the most important thing is the data. We have our read message system, and we have our different queue types, being a queue ship, a queue game state, all these other ones that you can see on screen. And when we receive that information, we place it into its respective queue. So as you can see, all our queues are there, and I'll go through the queues in a second. My input queue, I've called the in local queue. We have our different types. There's 5 types of information that I am sending currently. We have a current network value. This is our ID number that we assign to each object. Sorry, a network ID we assign for each object. So that way, when we place it into this map, relative to whatever number we've received, we have a reference of a game object that we can pull from when need be. When we process locally, we just pull everything out of our in queue, and we just call do work on the respective object. So it will either be a ship, client ship data will only occur if we are the client. Collisions happen between both client and server. Missile data only gets received by the client, and game states, which happens to both client and server. When a game object gets created, on top of its local ID, I've given it a network ID. So when we add, when a game object gets created, it gets added. It gets given a network ID, which is the current value, the current network value incremented +1 for the next object. We have a network value of 0. If it's ever that case, that's my this is no longer network, please avoid safety precaution just in case. I don't think I've ever hit this, but it's there. And when I remove something from the network, I remove it from my map, and I set its network ID to 0. That's my safety precaution, but it's not really needed. I have the ability to clear everything out of my queues, and the ability to set my current network value back to 1. This is for basically a hard reset. When the game gets terminated, we come back into this, we reset everything, and it's like starting up a brand new game. These are all of our in queues, one for each data type that was mentioned above. I'll go briefly into the out queue. We have a push to local, which is what our server pushes to itself. As you can see, it just goes directly back into the in queue. And it's important to note that we do not send ship client information and bullet information that you saw in the in queue previously. That information is only sent to the client. If I am the server and I'm pushing locally, I also push to the network. I push all the information that I have to the network. If I'm not connected, then I'll just clear everything out of my queue and I'll call it a day. But pushing to network, we will see we initialize our packet or our message that we're going to send. We give it its in sequence number, out sequence number, and its type. And then this is where the rest of the magic happens. We have our game states that get sent out because the client needs to know when the game state has switched, and the server needs to know when the game state is switched. The client will send ship information, which is basically physics stuff. The both the player and the client will receive collision information, but this mainly is for the client. This will execute the collision given two network IDs. The client also receives ship data and missile data, which the local client doesn't because, well, it doesn't need to update its position, but the other object, but the other instance, since it doesn't run on physics, does. And then at the very end, we clear out our local queue, or our out local queue, or our outward queue. So that basically covers the networking aspect of it. I'm going to go into the individual game objects. So the ship, given a type, will give a value, which is the int, in order to execute whether something has moved, has rotated, if something has fired, or if a mine has been lain, or if collision has occurred. This one is no longer used. This is something that I took from before because I was going to have each individual object have a collision information, but I realized that that was redundant since I have everything stored into my map with network IDs, so I could just call, hey, get these two IDs, give me the game objects at those two IDs, and then run the collision on those two. I'll show that in a second. But that covers my ship data. I have a type for it, a value for each one of these function calls, and a ship number. For the client, I have a special package, which is the ship number, the X and Y position, and the angle of that ship. So that way that the client can update the sprite relative to that information. So if I go all the way down, this is the stuff that has been modified. This used to be in the game manager, but I figured that the ship should be responsible for firing missiles and laying mines and getting all this information. So I moved this into the ship. It also made it a lot easier for not having to worry about sending over mine information. Everything is just based on the ship. But anyways, we have our do work function for a client. So when the client receives a client data packet, they will set the position and set the angle of their sprite to that. If the server receives a package from the client or from itself, and we call do data on it, it will depend on if it's a move, if it's a rotation, if I fired a missile, if I laid a mine, or the collision, which, like I mentioned, is no longer used because I found a better way to functionally do this. The missile, much like the ship, has this missile client data. Between the two of them, it probably would have been better to just have a generic like update sprite data, and then just have like instead of saying ship number with big quotes, it would be it would just be the ID of the object itself. So we would get the network ID of that object, go through hash it through the dictionary. The dictionary would give us the object, and then we just update that specific sprite's position. But I separated the two. Like I said, it probably would have been better to do it the other way. Going on, mine doesn't really need any information because once the sprite is put on the screen, it stays on the screen, and it kind of just does its own thing. The only important thing about it is a collision, but like I said, that is done by sending collision packets from the collision manager. Fence posts don't need anything special. Like I said, they're all added once the base game object is created. So the base game object is created, and that object is already automatically put into my network managed system, so I can give it an ID and I can receive the reference of that object. But going into contact that I keep mentioning, when it comes to collision, all that is important to me is the network ID of the first object and the second object. So when a collision occurs, we get the game objects. And what I do is I create a new collision data that I'm about to pass out into my output queue. And I say, okay, I know the network ID of A and I know the network ID of B. So later, when the in queue processes the work, I just pull these from my dictionary, both of them. And now at this point, I call my double dispatch on A and on B. And that in turn will go into each one of the objects locally and execute what occurs on hit. This was a much faster way of handling a collision, because before I was going to do the thing with the ship where I have ship collision, and then I was going to have another enum type between a collision between ship and this other thing, and I would have to calculate all that other stuff. But in this way, almost everything is handled for you. You avoid switch statements as much as possible because you have the game objects in and of themselves on each local side. Going into the game, for the update, the very first thing I do is I do my deferred removal. I don't think this matters if it's in the beginning or the very end, because it will just be called after everything has been done. The very first thing I do in terms of my additional code is I ask the network listener if I've received any messages, and that gets put into the appropriate in queue or out queue. Or sorry, when I listen to a message, I process them out and it goes into my in queue. Then if I am the server, which is what this Boolean is, then I simulate physics on the world. If I'm a client, I don't even worry about it because that's just extra work that isn't even required. And then the other things that happen is I take my output queue and I push everything out. Either I push it locally or to the network. As I've shown before, this isn't just local. It's local and to the network, and the messages that go out to the network depend on whether or not you are a client or a server. And then the in queue is you get the in queue basically from the receive messages or whatever you just pushed out and came back into yourself. So it kind of does a lot of extra things between these two, but this is the process that basically I added onto this. I'll go through the checklist just to make sure I've covered everything. You've seen my input queue, it's in local queue. My output queue is out local queue. I've shown the various types of information, ship, game states, collision, client, and missiles, basically for setting the positions. Is there anywhere in the code where you send or receive data from the network that isn't in a queue? No, everything is processed through the queue. It either gets put into the output queue and then automatically gets put into the input queue and then executed, like basically not even within a frame because it's right after the other. But almost everything is handled by queues whenever possible. In terms of all the change list stuff that's associated with data-driven stuff, at the very bottom of the screen, I have all my change logs with all my notes on to what I did and what I learned from each one of those processes. In terms of the lobby, I think I've explained it. You start off as a client trying to connect to a given IP with the port 60641. If you find the connection, you connect and you're great. If not, you become the server. And then the second computer will have to try to connect to your local IP address at port 60641. I've shown how I initiate a game. I've explained that I use a map of of network IDs with my with a reference to each one of my game objects, so I can pull. I can just send the ID numbers, and I can just pull out the game object that is comparable to that number on the other machine. So that should be fine. The biggest bonuses about the data-driven is once I was able to make firing missiles and laying down mines data-driven within the ship, it saved a ton of work immensely. In terms of the lobby, it was a bit tricky switching between or knowing how to determine when you haven't connected, but Spencer in our class was able to lead me in the right direction for this process. So that's a big shout out to him for helping on this thing. In terms of moving ship, what information am I sending? If I'm the client, I send basically physics information to the server so that the server can process that information. If I am the server, I send back the position and rotation of where the ship should be. Bombs, the only thing that gets sent is basically, hey, a bomb is here, and then if a collision happens, that's handled through the collision manager and through a collision packet. Missiles, when a collision happens, that's the same thing, but on both sides, the command is sent for the creation, and the server will basically handle the physics and just tell the client, hey, here's the position, here's the rotation, and then when it's gone, the collision happens and it gets marked for deletion, everything occurs. How do you differentiate? I mentioned that I use unique network IDs that gets put into a dictionary, which is basically just a map, and I can pull the appropriate things in and out of it. Where the collision's controlled, that's all done on the server side. When the server interprets that a collision has occurred, it sends out to the client, hey, this unique ID and this unique ID have collided. And then it's on the job of the client to say, okay, I know what these two objects are. Do the double dispatch and call the collision on it. If any information is updated or changed, send that back out to the server, and then we are done. In terms of the summary for collision, as I mentioned, I tried to do it a really weird way, and before using the map, I tried using an array, but coding defensively using the array probably isn't the best idea, considering that if a programmer would decide like, hey, instead of shooting 6 missiles, I want to shoot like 600, an array really isn't good defensive coding. But I tried a linked list, but the linked list basically messes with the numbering of things. Also about the array, if I don't use all cells within the array, I'm basically wasting memory. I know it's C#, but it doesn't seem like the smartest thing to do. So I ended up using the map so I could take in a given unique ID and then just point to the correct object. And like I said, it made collision a whole lot easier than trying to do what I was trying to do with having each basically do call on my input, on executing everything in my inputs. Instead of having that, call this specific visitor of a ship, this specific visitor of that, I just send in the 2 IDs and I say, hey, you know what to do, because all that has already been coded in the background for this system. Anyways, I think that covers all this information. Like I mentioned, it's all within this the final project. I have both the checklists there, the final for both the client and the server. I'm sorry that I don't have two computers to fully test it on, but like I said, just typing in the IP address should work. It worked at DePaul, um, except for one instance where something kind of messed up, but I think it was the administrator rights. Um, but other than that, thank you very much, Ed, and hopefully I'll see you soon.